Beam me up, Scotty. It is one of the most famous phrases in science fiction. In Star Trek, teleportation is a convenient way to get from a spaceship to a planet without landing. You stand on a pad, you dissolve into shimmering light, and you reappear instantly on the surface. It is clean, it is efficient, and it is the ultimate dream of transportation. Imagine commuting to Tokyo from New York in 0 seconds. No airplanes, no jet lag, no travel time. But science fiction rarely stops to ask how the machine actually works. If you look at the physics required to make teleportation happen, the dream quickly turns into a nightmare. The technology doesn't move you. It doesn't slide you through a wormhole or push you through a dimension. To move you from point A to point B instantly, the machine has to take you apart, atom by atom. It has to read the position of every electron, every neutron, and every neural connection in your brain. Then, to send that data, it has to destroy the original structure. When you rematerialize at the destination, you are a brand new construction, a perfect copy. This raises the most terrifying question in philosophy. If you step into that machine and are deconstructed, did you just travel? Or did you just commit suicide, and a stranger with your face walked out the other side? Let's look at the hard science. Is teleportation actually possible? Surprisingly, the answer is yes. We have already done it. In 1997, scientists successfully teleported a photon. Since then, we have teleported electrons and even complex atoms. But we aren't throwing the particle across the room. We are using a phenomenon called quantum entanglement. Here is the catch. In the quantum world, you cannot measure a particle without changing it. This is the Heisenberg uncertainty principle. You can't just scan a human body like a Xerox machine. If you try to measure the exact state of every atom in your body to copy it, the act of measuring it disrupts the state. You get a blurry image. To get a perfect scan, which you need unless you want to arrive on Mars with brain damage, you have to extract the information completely. This is governed by a rule in physics called the no-cloning theorem. It states that you cannot create an identical copy of an arbitrary, unknown quantum state. You cannot have the original and the copy exist at the same time. So, to teleport you, the machine must extract every bit of quantum information from your body. In doing so, the original state must be scrubbed. The original you doesn't just disappear, it is physically destroyed to fuel the data transfer. The machine at point A is not a teleporter. It is a shredder. The machine at point B is a 3D bioprinter. It uses the data from the shredder to build a new you out of local atoms. It's not travel, it's faxing. And just like a fax, the original sheet of paper doesn't go through the phone line. This brings us to a paradox that is over 2,000 years old. The ship of Theseus. The Greek historian Plutarch asked a simple question. If you have a ship, and over time you replace every single wooden plank, every sail, and every nail until no original parts remain, is it still the same ship? Most people would say yes. It maintains the shape, the name, and the history. But then Plutarch twists the knife. What if you took all the old rotten planks you removed and built a second ship out of them? Now you have 2 ships. Which one is the real ship of Theseus? The one with the fresh parts, or the one with the original matter? You are the ship. Every 7 to 10 years, the vast majority of cells in your body are replaced. You are not made of the same stuff you were made of when you were a child. You are a constantly regenerating biological pattern. So, if teleportation is just a faster version of this natural replacement, why is it scary? The difference is continuity. When your cells replace themselves, it happens slowly. The pattern of you is sustained without interruption. There is a continuous stream of consciousness. In the teleporter, that stream is snapped. There is a hard cut. Point A, you dies. Point B, you is born. Point B, you thinks he is the original. He has your memories. He remembers stepping onto the pad. He says, "Wow, that worked." But he is wrong. He is an imposter who inherited your life 1 second after you were incinerated. Let's make it worse. Imagine the teleporter malfunctions. You step into the machine at point A. The scanner scans you. It sends the data to Mars. The machine on Mars builds a perfect copy of you. But the shredder at point A fails. You are still standing on the pad on Earth. You check your phone. You see a message from Mars. Arrival successful. You are now looking at a live video feed of yourself on Mars, waving at the camera. That person on Mars has your memories. They love your family. They know your passwords. They are you. But you are also here. Clearly, you are two different people. You are distinct conscious entities. If you shoot the one on Mars, you don't feel the bullet. Now, the operator steps into the room. He says, "I'm sorry, sir. The policy is strictly one person per ticket. We have to complete the procedure." He pulls out a gun. To teleport, you have to be destroyed. If you would beg for your life in this scenario, then you have to admit that teleportation is murder. The only difference between this glitch scenario and a successful teleportation is the timing of the death. In a successful jump, you are killed before the copy wakes up, so no one notices the crime. Teleportation forces us to confront the uncomfortable truth that we are not our physical bodies. We are the information contained within them. But information can be copied, edited, and deleted. If we ever invent this technology, it will change civilization. We could conquer the stars. We could cure death by printing backup copies of ourselves. But the price of admission is the original self. The you that steps into the machine never steps out. The universe continues. Your work continues. Your life continues. But you do not.